Good evening everyone. So now today we are going to discuss measurement and we will try to cover today a special topic of measurement, error analysis, PMMC and moving iron instrument. Now dear friend, moving iron instrument and PMMC are very important topics for the measurement, and as we know that every year they ask minimum 1 to 2 marks from these two topics. Okay, I'm not going to say here ki that means error analysis is less important, but definitely if we compare these three topics, so error analysis is somewhat less important. Okay, but at least we should know about the error analysis concepts also. So before discussing like these instruments in measurement, I would like to discuss something about error. Okay, so somebody please tell me. Yeah, hi everyone, good evening. So yes, somebody tell me what is the main purpose to learn the control system. Somebody please tell me what is the main purpose to learn the control system. Yeah, good afternoon, good evening Dilip. Yeah, somebody please tell me what is the main purpose to learn control system. I'm giving to you option. It is stability, it is controllability, it is observability, or desired output, or to control error, whatever. So according to you, which option may be right? What is the main purpose? See everyone, in control system we have two different type of system in general. First one is open loop system, second one is closed loop system. We know that in open loop system feedback is absent, and in closed loop system feedback is present. Yeah, Karthik replied to get accuracy. Okay, so we will discuss. So open loop like feedback is not present, and closed loop feedback is present. Now please somebody tell me what is the main purpose to provide a feedback to any system. Okay, to provide feedback to any system. My dear friend, to provide feedback to any system, the main purpose behind it is nothing but to identify the magnitude of error. I repeat, to identify the magnitude of error. Now, by the using of different types of controller, we can control the amount of error. But it is impossible to control that error fully. Okay? Okay, we will discuss everyone. Just listen to me carefully. It is impossible to minimize that error up to the level of 0. Okay? So to make 0 error, it is kind of impossible. Now, with the help of feedback and controlling circuit or controlling devices, we can improve the magnitude of error. Improve means we can decrease. Okay, my dear friend? Yeah, now I'm going to consider your answers according to input, observe output, check output, okay, whatever, to rectify error for stability. Dear friend, to learn control system, our main purpose is not stability. Our main purpose is to get desired output or to get output with minimum error. Clear? To get output with minimum error. That is the main purpose of control system. Now we know that we use control system everywhere, either to learn power system, to design power system model, to design electrical machine model, etc. All these things. So we are, or we can say, measurement like subject wise is present everywhere in analog, in EDC, whatever subject we are dealing. Now most important thing, we have two different type of devices, analog and digital. We know that electrical machine and power system provides high error and low efficiency. Everyone, high error and low efficiency. What about power electronics? Power electronics, by using of different type of controlling switch, we are capable to control our output, and we are capable to achieve desired output almost with minimum error. So power electronics is most like advantage wise, okay, or power electronics provide more advantage in comparison to electrical machine like core or power system, because these two fields provide very low efficiency, dear friend. That is the most important thing. Okay, so is year gap 6 years beneficial for the GATE IISc preparation? Okay, let us discuss this question. Dear friend, 6-year gap is definitely considerable gap. And directly I'm not going to say you should prepare a preparation about GATE or IISc. But if you are in job, if you are touching like your subjects, okay, and if you have well knowledge of your subjects, well means like hardly 30 to 40% knowledge of your subject, you can start your preparation. Okay, please mind it. And rest thing, Rohit, we will discuss sometime later. Now everyone, so power electronics is kind of modified version of control system. And there is no big difference. In control system, we use whatever devices like P controller, PID controller, that type of devices. In power electronics, we can replace by electronic devices or switches. Okay. So now pause this particular thing. Now again I am going to ask one very simple question. Please listen to me carefully, and somebody if possible reply also. We have two type system in control system, open loop and closed loop. Which system is going to offer high error, open loop or closed loop? Listen to me carefully. Which system is going to offer high error? Is open loop or closed loop? Yeah, somebody please. Okay, meanwhile, I am going to discuss with Rohit. No job, okay, no issues. See, Rohit, first try to understand the all basics concept and give like 1 to 2 months for the study to learn the basic concepts. And after completing this portion, try to find out the like few problems from GATE or IIS, and whether you are capable to handle those problems, then definitely you can do it. Okay, just try to understand basics first. Okay, good evening, Shalu. And yeah, open loop, closed loop. My dear friend, you are going to write IISc or whatever GATE exam. It is not good answer from your side. Okay. What I asked question, my question was, which system will offer high error, open loop or closed loop? Okay, I'm going to make this question very easy. Okay. Yeah, tell me just in comparison, open loop system will provide high error or closed loop system will provide high error? Or now it is very easy. Open loop system will provide high error or low error? Somebody please tell me. Open loop system will provide high error or low error? Yeah, please somebody. Good evening, Ashu. Yeah, today we will learn each and everything in very like with lot of concept and in very like time taking process. Okay, so there is no hurry. Try to understand each concept and we will discuss about each concept in depth. Please mind it. And try to today lecture, okay, I'm not going to promise you because it depends upon your study how you are in measurement, because everyone knows that power system, power electronics or machine are, I think, familiar subject or good subject for electrical core. But today it depends on you. Okay, so open loop, in open loop error is not calculative. Okay, open loop. So now I'm going to reply. My dear friend, you know very well in open loop system feedback is not present. Okay, कहानियां सुनाने का समय नहीं है. Try to understand all these things. Good evening, Kuldeep. First, most important thing is that in open loop system feedback is not present. If feedback is absent, how can we calculate magnitude of error? It is kind of impossible. Please try to understand. It is kind of impossible. So open loop system error is not defined. Maybe it is high or low. That system will, please mind it, that system will decide after applying feedback. But before applying feedback, open loop system error is not defined at all. Please mind it, okay? So that is the most important thing. Now I'm going to ask you a very simple question. Let us consider all the examples, and my dear friend, try to understand the basics of measurement. If you are capable to understand whatever I want to deliver, it's my promise you will minimum score 1 to 2 marks from today class itself. Okay, so just try to understand first all the concept. Here, this is my bit introduction. I have done MTech from IISc Bangalore. My name is Ravi. Okay, so now I'm going to take one example here, beta. Let us assume this is the VI characteristics of diode. Please mind it. This is the VI characteristics of diode. Now somebody please tell me, diode is a non-linear device or linear? It's performance wise. Okay. Yeah, please. So listen to me carefully. Somebody asked how that is possible. Open loop system provide low, like not defined error, or error is not defined in open loop system, but error is defined in closed loop system. So somebody has some doubt. Okay, let us consider that particular concept with an example. Okay, now somebody, can you reply me? Okay, wait a moment. I'm going to ask a very simple question. Very simple question. Now, can you say something about, please mind it, can you say something about SOM, strength of material? That is a different subject, not your electrical branch subject. Yeah, somebody please tell me. SOM. See, my dear friend, SOM or with SOM, we are not familiar. If we are not familiar with strength of material, how can we give any feedback? It is not possible. So when comparison is not there, we cannot determine error. So in open loop system, whatever we are providing input, we are getting some output without any comparison. So comparison absent, and that gives guarantee error is not defined. It is clear to everyone? Okay. So a diode is unipolar, unidirectional device. Okay, Mahesh. And non-linear, yes, non-linear. Everyone are going to reply it is non-linear. Almost answers are non-linear. Please mind it, my dear friend. Everyone knows it. Diode is a non-linear device. But sometimes we consider diode is linear device. Okay. What is the main reason behind the linear characteristics of diode? The linear characteristic of diode. Dear friend, diode operates at a very high frequency, generally in terms of kilohertz. When any signal performance switching period appears for very low time interval, almost impulsive. Listen to me carefully, almost impulsive. When any signal appears for almost impulsive period, it is nothing but in terms of milli, micro, or nanosecond. Then that characteristics, that performance, we can consider like linear. Because that non-linearity is almost negligible, dear. That non-linearity is almost negligible. That same thing we apply in power tonics. That same thing we apply in power tonics. But dear friend, that same thing we cannot apply in electronic devices and circuit. That means EDC. Why? Because EDC is nothing but a subject, and in this particular subject we want to learn how to design the devices, what will be the actual performance. So with respect to designing, we are not supposed to consider diode characteristics is piecewise linear. Listen to me carefully. With respect to designing, we are not supposed to consider diode characteristics is piecewise linear. But application wise, when frequency very high, we can consider it is almost linear. For example, in analog as well as in power electronics. Please try to understand. So most important thing is where we can consider non-linear and where we can consider linear. These two parameters are most important things. Most important things. Now dear friend, if we consider non-linear, here with respect to temperature change, we have R on, which is change in voltage by change in current. And in piecewise linear, we can consider sometimes R0, sometimes R constant. So dear friend, diode practical characteristics provide dynamic resistance, whereas diode ideal characteristics provides constant or static resistance. That is the main difference between the error and without error. So sometimes when error is almost negligible, we can ignore it, otherwise it is not possible. Please try to understand. Okay, thank you everyone. Now listen to me carefully again. Diode or any electronic device, any electrical circuit, any motor, generator, power system, whatever, including us, okay, including us. See, sometimes we say someone to, please mind it, we say something to someone, okay, and after few moments or hours, somebody realized that, yeah, you said something wrong to someone. The moment at which you were delivering something to someone, that time we were not realizing whether our sentences will hurt someone or not. But after some time, somebody said us or suggest us that you said something wrong to that person. We realize that and we say sorry to him or her. My dear friend, that is the actual life. Okay, that is the actual concept behind the error. Sometimes we are not capable to realizing, means error is present, but we are not capable to find out that error. Somebody provide feedback, what you did, then we realize it. And we want to clarify those things. So these are the most important things regarding error analysis. Please try to understand. So every system has error. If we provide feedback, we can calculate almost exact error, but in general it is impossible to control that amount of error fully. Yeah, definitely we can control, but not absolutely. We cannot make absolutely it zero. That is the most important thing. So these requirement born a new subject in our field, and that subject is nothing but, dear friend, measurement. Please mind it. Okay. Now let us consider a few basic concepts of error also. Before that, again I would like to ask you very simple question, and a question is nothing but wait a moment, Pawan, wait a moment, listen to me carefully everyone. Now my question is, can we, or is it possible to identify true value of any system? Is it possible? Or can we determine true value of any system? Yeah, somebody please reply by just yes or no. Is it possible to calculate true value of any system? Please somebody reply. Yeah. How could you take as a piece continuous? Yeah. Please mind it, Pavan. It is not continuous. It is piecewise. Okay. So listen to me carefully here, Pavan. Dear friend, from this portion to that portion, in ideal case, we can assume our diode is off. But after some time, when we provide some positive voltage across the diode, diode will get turned on and may provide either this characteristics or this one or that one or maybe this one. It depends which type of elements are present inside the diode. That means V gamma and R on. If V gamma, R on both are present, we have to consider this characteristics. If only V gamma is present, we have to consider this one. If only R on present, we have to consider this one. If both are 0, then this is our ideal characteristics. So these characteristics are not continuous. Please mind it. These are piecewise linear characteristics, like piecewise. Okay. Yeah. So I'm going to take another doubt. Yes, by numerical analysis, we measure true value without error. Okay. So somebody reply me, listen to me carefully again. It is impossible, listen to me carefully, it is impossible to identify true value, Om and everyone. It is impossible to identify true value, absolute true value, it is impossible. Why it is impossible to calculate absolute true value? Reason is nothing but, my dear friend, to calculate true value, we always use n number of measurement. Like in general, we can say precision. And please mind it, precision is not always a guarantee of true value. Is not always a guarantee of true value. There will be always some finite error. There will be always some finite error. For example, suppose, I am going to take one example, dear friend. Suppose we have here one pole, and I am going to ask very simple question. What will be the height of this pole? Yeah, somebody tell me please. What will be the height of this pole? Yes, everyone. Yes. So, sir, I didn't study measurement, get 2 marks with this lecture. Okay, yeah, definitely, Harshal, I will try to, okay, explain each and everything, but just listen to me carefully, okay? Now my question is, what will be the height of this pole? Dear friend, you know very well, nobody can reply it. Nobody can reply it, okay? So now try to understand. Here, I'm going to indicate some marks, okay? For example, this one, first one, second one, third one, fourth one, fifth one, and this is 6. And every is 1 feet, okay? Every gap is 1 feet. Now, can you tell me what will be this height? Yeah. Good, Kailash. That is the answer. We can't say anything. None. But now we can reply it. So I'm going to say, my dear friend, suppose this is the pole height. This one is the pole height, okay? And I am going to ask a very simple question. What will be the height of this pole? So suppose somebody replies, Sir, 1 feet is this, and how many sections? 1, 2, 3, 4, 5, and 6. So somebody can reply, Sir, just more than 6 feet. Just more than 6 feet. Try to understand. In measurement, they will ask minimum 1 marks question from the theoretical portion. And that theoretical portion not will be easy, okay? We required basics idea regarding resolution, sensitivity, error, true value, absolute error, limiting error, whatever. Okay. So now try to understand. Here somebody replies, sir, just more than 6 feet. Now I ask very simple question. How much more than? Now nobody knows it. Please mind it. Nobody knows it. Why, beta? Because here we don't have this gap, my dear friend. We don't have any knowledge of this gap. So now we will say this is just more than 6 feet or maybe 6.1. But now try to understand. Somebody provide beta a low scale in between. Suppose for example 1, 2, 3, 4, 5, 6, 7. Like this something. Now you can say 6.2. Again somebody provided very low scale. Okay, let us assume, my dear friend, very, very low. It is not possible to draw it. Okay, now you can say 6.232. Like that every time when we provide a good resolution, repeat, good resolution, we will get a close answer which will be very close to true value, kind of. Okay, so when we will provide like very low scale, or a scale which can measure very, very low value, which is very, very low value, that low value scaling will provide high accuracy, dear friend, will provide high accuracy. But kind of it is impossible to tell exact length of this. So universe wise, we are taking like some length, anything like weight or whatever, with some error. That error is always finite and definitely not zero, dear friend. Definitely not zero. So please try to understand, it is impossible to identify true value. Okay, but we can achieve a value which is very close to true value. A value which is very close to true value. So there is a lot of difference in between true value and measured value. Okay, measured value always has some error, and we assume that true value is free from error. Please mind it, every word. Measured value has finite error, and true value we assume that is error free. Actually, true value also has finite error. Please mind it. Now, I think it is clear to everyone. Now, dear friend, what is precision? Precision is nothing but reproducibility. Listen to me carefully. I will not take like more than a minute for every definition. Precision is kind of reproducibility. Precision may or may not be guarantee of accuracy or true value. Okay? For example, my dear friend, dowry is a bad thing now, but it is happening from last maybe 1000, 2000 of years. Still, it is going to happen. Dear friend, that is bad thing, but it's still going on. So this thing is precise but not accurate. This thing is precise but not accurate. So please mind it, precision in general not guarantee of true value or accuracy, not guarantee. But precision is the guarantee that reproducibility is happening. Means whatever we are getting result, that result are going to produce again and again. Okay, just wait a moment. Mahesh is asking, what is resolution? Dear friend, resolution is nothing but, suppose you can say, we are going to provide a scaling factor. Just wait a moment. So you can try to understand this resolution term in very good way. Try to understand, my dear friend. Suppose, dear friend, we have one scale. Okay, and this scale, suppose 6-inch scale. So these are 1, 2, 3, 4, 5 and 6 inches. Now, meanwhile, try to understand, when we like observe or when we measure anything by a scale, we can measure maximum in terms of centimeter. Listen to me carefully. In terms of centimeter. So the minimum reading that scale can read, in general, I'm going to say 1 centimeter. So what is its resolution? Its resolution is 1 centimeter. Please try to understand. Its resolution is 1 centimeter. Suppose that scale is going to read 1 millimeter, then its resolution is 1 millimeter. If it is going to read or provide data like for nanometer also, then its resolution will be 1 nanometer. So resolution is nothing but, in practical language, the minimum like criteria or scaling which can measure or read by a person. That is called resolution. Please try to understand. So whatever we provide input, with respect to that, if we are getting some output, then that proportionality is called resolution. Okay, so it is clear to Mahesh or any doubt? Just wait a minute. Regulation is inversely, not regulation, dear friend, it is resolution. Okay, resolution is inversely proportional to sensitivity. Okay, Preeti, we don't have any such relation. Please mind it. We don't have any such relation in terms of resolution and sensitivity. Sensitivity is a different task and resolution is a different task. Again, listen to me carefully. That's why I'm going to say it again. Please try to understand the basics. Okay, what is the meaning of resolution as well as sensitivity? We are going to deal both simultaneously. Okay, resolution means the minimum change. Please try to understand. The minimum change in output is readable or measurable by us is called resolution. What is the meaning of sensitivity? Try to understand. Dear friend, suppose we want to operate a valve in our room. We want to operate a valve in our room and we have a voltage regulator. In our room, supply is 230 volt 50 hertz. And with the help of that voltage regulator, we make that supply 0. It means our bulb or load is receiving 0 volt. Please mind it, is receiving 0 volt. Okay? Now try to understand. That bulb will not glow at all. Now we want to vary our input supply by very minute change, very small change. So now we make input supply 0 to 1 millivolt and we observe that still bulb is not glowing, and we have connected some meter. Bulb is not showing any amount of current, just we assume. Now dear friend, we again vary our input voltage and now its voltage 1 volt. Due to that 1 volt, we observe that whatever ammeter is connected with our load, that ammeter is showing very small current, very small current. Let us assume 1 nanoampere. Due to 1 volt apply or change of 1 volt, we are getting first current in our ammeter, that is coming 1 nanoampere. That is called sensitivity. Please try to understand. That is called sensitivity. Whatever change in input, if same change is coming in output, if that ratio, that criteria is satisfied, then we can say this ratio is nothing but our sensitivity. That ratio is nothing but our sensitivity. Yeah, so Mahesh said to me, inversely proportional to scaled value. Yeah, it is definitely right. Okay, listen to me carefully everyone. Whatever we are going to provide is scaling to our meter. If that is scaling, we have adjusted so that a minimum change in input is showing change in output. That is called sensitivity. So sensitivity we can roughly define change in output by change in input. Yeah, any other boss? Okay, so I think it is clear to everyone. If you have any doubt, please let me know so that we can discuss all those things in detail also. Yeah, please somebody tell me. Okay, so now we are going to discuss something about more error analysis, like which type of components in general we have in measurement. Okay, in measurement we have different types of components, my dear friend. For example, resistor, inductor, capacitor, electronic devices, BJT, MOSFET, op-amp, etc. Mechanical devices. Okay, so we can observe that measurement is not only the subject of electrical engineering. It is also useful for the better understanding of electronics, mechanical, civil, or any other branch. Dear friend, please mind it. Or any other branch. Okay, so now we are going to discuss something or formula about thank you Dharam, please try to understand. Now we are going to discuss some formula related to like multiplication, subtraction, addition or division terms. Now we know that we are not supposed to waste our time in that or regarding this analysis, but just try to understand, dear friend. When we add 2 or more quantities, we have to add, listen to me carefully, we have to add absolute error directly when we want to add or subtract 2 or more quantities. Absolute error. What is the meaning of absolute error? Absolute error is nothing but the error which is the difference between measured value and true value. Please mind it. And also try to learn it or try to understand this thing. Dear friend, the magnitude of error will never affect by either you can subtract true value minus measured value or measured value minus true value. So whatever you want to take or consider, you can consider that result. But before considering this result, you have to take mod of, like mod of measured minus true or mod of true minus measured. That difference will always provide absolute error. What is the limiting error? Okay, thank you Anil. What is the limiting error, my dear friend? Limiting error is nothing but the ratio absolute error divided by true value. Absolute error divided by true value. So these 2 points you have to keep in mind. So when we want to add or subtract two or more than two values, we have to add simply all absolute error. Just listen to me carefully, all absolute error. But in terms of multiplication or division, we have to add all limiting error. All limiting error. That is the thing. And when we have squaring terms, then square or power terms will multiply with the amount of limiting error. For the better understanding, I am going to take few examples related to this. Okay, dear friend, just try to understand each thing in very relevant way and minimum time, so that we can cover more and more examples. So here we are going to take, dear friend, let some value z, which is nothing but x plus del x plus y plus, wait a moment, plus y plus del y. Okay, something like this. So there is some quantity x which has finite error, there is some quantity y which also have finite error, and these components are absolute error, not relative error. Not wait a moment, I am getting some doubt. I don't know very well. Your explanation is very clearly understanding. Thank you so much, sir. Okay, thank you, stylist. Now, dear friend, x plus del x something, y plus del y something, these like terms are absolute error. What is the way to represent limiting error? The way to represent limiting error is nothing but, my dear friend, some error in any function divided by true value. See here, true value is not present. And limiting error or relative error is always provided generally in terms of percentage. Here, percentage terms are also absent. So that value of z is nothing but x plus y plus minus del x plus minus del y. This is our final answer. Please try to understand. Wait a moment, dear friend. It is not like this. So here we are not supposed to use our this sign minus. So here we have to use only plus sign. So plus minus del x plus del y means we have to add both errors or more than this, all error. Okay. Simply first try to understand all errors must be in. Please try to understand, dear friend. Again, I am saying absolute error, not relative, absolute error. Now, dear friend, suppose we have z equal to x this term minus this value. Okay. So x minus y. So this result will change. Now we have to replace this plus by minus sign. This plus by minus sign. But that component will not change, will not affect. Please try to understand. Now, dear friend, we want to calculate error for the multiplication values. For example, I say z is equal to ABC. Okay. And I say roughly A has some error, A percentage or del A, and B has some error, del B. Okay. And C has some error, cell. This one. Please mind it, everyone. Now, dear friend, del A percentage. So all are relative error. Okay. Hello, Dimpy. Now, del A, del B, del C, all are percentage error. Now, dear friend, that percentage error we can directly add in multiplication or division. I repeat, or division. So here our values are nothing but A, B, C multiplication all plus minus del A plus del B plus del C. This is the thing. So in multiplication we have to use that formula. Okay. Yeah, Preeti, it is absolutely right. Okay, beta ji. So this is the thing. Now, dear friend, suppose somebody give us an example in this way, A by BC, and all values ABC are same. In that case, only that component will change, and this value will be A by BC, but that error will again same. Dear friend, please mind it. That error is again same. Okay. So thank you everyone. Now, Betaji, please mind it. Now this is the last thing. Suppose, dear friend, we have some z is equal to a to power m, b to power n, and c to power suppose o. Okay. Now, in this case, what will be the error? Just see. Here, suppose we have A plus, sorry, A plus minus some del A and B plus minus some del B and C plus minus some del C. Okay, all these things. And here power, dear friend, M, here power N, and here power O. So we can write this equation A to power M, B to power N, C to power O is first thing. Now, some error also be required. So plus minus overall is nothing but M into error of del A plus N into error of del B plus O into error of del C. It will be good if all error will be a relative error. That is the thing. Try to understand. These are very, very important formula, and these formula we can easily apply for different type of examples of error analysis. It is clear to everyone, or should we take more example or more analysis? Yeah, please somebody tell me. Okay, so few examples we will handle here, and few examples I will give you for the homework. Dear friend, in tomorrow's session, if you have any doubt in those problems, you can ask to me like meanwhile, okay, in the lecture. So it is not a big issue because we want to cover more and more topics so that you can take just a brief idea about the topics, for example, PMMC and moving iron instrument. So I'm going to ask a very simple example, and this is our first example, dear friends. Okay, somebody tell me fast, what will be the answer of that question? Yes, everyone, please try to solve it. Take a pencil and copy or pen, whatever. Yeah, definitely. Mahesh, we are considering some examples also related to the same thing. Okay, don't worry. Yeah, somebody please tell me, and after taking this example, we will cover two to three more examples also for the better understanding. Please don't worry. So yeah, calculate the maximum error in the sum of two voltage measurement when. Yes, everyone, please, somebody reply. Okay, 7. Yeah, so somebody said me, Ganesh, it is 7. Yes, everyone, please reply fast. Do it fast, please. Okay, so see, my dear friend, first here, most important thing is nothing but this. 2% and 5% is the error. Try to understand, everyone, Ganesh and Preeti, everyone. We are doing same mistake again, my dear friend. See, here error is in terms of percentage. Here error in terms of percentage. And percentage error, that means relative error or limiting error, we are not supposed to add. I repeat, we are not supposed to add directly when we want to add two quantities, when we want to subtract two quantities, etc. Please try to understand. So 7% unfortunately is wrong. Okay, yeah, so Ajay replied it is 2.73. So now we are going to consider V1 has error 2%. I don't have calculator, so please you try to calculate all those things. First tell me V1 is 200 plus minus how much absolute error? How much absolute error? Yes, 1.98, 2.73, 7.25. Yes, we will discuss, my dear friend. So 200 plus minus 2% of 200. How much it will be? Yeah, means is that all error are always right. Okay, means wait a moment, everyone. Shalu replying means is that all error are always right. I'm not getting properly. Please explain that thing again. So here we have to take 2% of 2. So it is nothing but 2 into 200 by 100. Sorry, 100. So that value will be, I'm not sure whether my calculation is right or not. So please try to understand all these things. So 200 plus minus 4 volt is first one. And now second one, what will be the value of V2? V2 is nothing but 65 plus minus, here minus also, so 65 into 5 by 100. Yeah, please somebody tell me how much this value we are getting. So that is so I don't have any idea, my dear friend. So here just calculate this value first. Okay, so let us assume, I'm going to assume here this value is coming, suppose some del V2, okay, del V2 absolute error, and this is del V1 absolute error, not a relative error. Please mind it, not a relative error, okay. Okay, so Vishal is replying it is 3.25. So I'm going to write here, my dear friend, 65 plus minus 3.25. Okay, so we have to add both values, calculate maximum error in the sum. Sum means here I'm going to write V is equal to V1 plus V2. V1 is 200 plus something, V2 is 65. So 265 is nothing but 265 plus minus 4 volt this and 3.2 this. So is how much? 7.25 is absolute error. Yeah, so whatever person replied 7.25, in terms of absolute it is right. Please mind it. It is absolute right. Now what will be the percentage error or relative error? No, beta. Please mind it. Mahesh, something, please don't do that type of silly mistake also. Try to understand. Here 265 with absolute error of this one. So what will be the relative error? Relative error is nothing but, suppose I am going to write here V is equal to 265 plus minus, it is how about 7.25. So 7.25, okay, is absolute. So what will be the percentage error? So here we can write V is equal to 265 plus minus error in terms of percentage, and that error in terms of percentage is nothing but 7.25 divided by 265 something. Yeah, please somebody tell me. So I'm going to take answer of Shalu. It is coming, yeah, 3.25. Somebody is saying 2.735. Okay, I'm not sure which one is right. So please try to understand. Here we have to write 7.25 divided by 265. So yeah, Preeti is replying 2.886. I'm like bit confused. So I am not sure which answer I should consider. So roughly I'm going to write here 7.25 divided by 265 is our final answer. Please mind it. Okay. So that is the thing. Please just mind it. Okay, Vishal, I'm going to take 2.78. Okay, somebody also replies this value. So it is 2.78. So I'm going to write here 265 plus minus 2.78% is our final answer. Now, dear friend, we are going to take another example for the better understanding so that we can learn each and everything. Okay, now try to understand from this example. Suppose, dear friend, we have some A value A plus minus some del A, and B value is B plus minus some del B. Okay, please try to understand these error, whatever I mentioned here, del A and del B, are absolute error. Okay, I'm not sure, Vishal, what is the right thing. Okay, just try to understand. 100 se multiply whatever you can do. Okay, so that is not big issue. Calculation wise, you can do it. So mine was first answer correct. Okay, Ajay. So definitely congratulations for it. Now, dear friend, here I think you are getting some doubts. So that's why I'm going to take another example. Another example is nothing but, dear friend, A is equal to A plus minus del A and B is equal to B plus minus del B. So we can think over it. A plus B is equal to A plus B plus minus del A plus del B. Okay. Now suppose we want to calculate relative error in the quantity of addition of both A plus B. We can write, my dear friend, del of A plus B. That means resultant error in this, and percentage wise. So is nothing but del A by A plus del B by B is the relative error in the overall addition. Please try to understand. So this is the main thing. Yeah, Venkatesh, I'm going to take one example from your side. Sir, some problem in take error of values of power. Okay. So yeah, definitely we are going to take another example related to power. Okay, please mind it, related to power. So here, just try to understand, dear friend. Suppose we have one R of 10 ohm and I is flowing 2 ampere. And these both elements are error free. Please mind it, both elements are error free. Then obviously error in the power will be 0. So suppose, dear friend, we want to calculate power dissipated by resistance. And now we are going to change the values of resistance and current. Let us assume that resistance is 1% and 2%. Okay, so this is the value of I. Now we know that, dear friend, what is power? Power is nothing but I square into R. So power is equal to I square into R. Here we have both things, powers and multiplication. I told you, dear, in power and multiplication, to calculate error is very easy. First, try to understand your error must be in terms of relative, that means percentage. So here that error is given in terms of percentage. If it is given in absolute form, first try to understand, convert all these absolute error into relative. Then you can apply those formula. So P is equal to I square R, and that quantity we can write, my dear friend, 2 plus minus 2% square into 10 plus minus 1%. So that quantity is nothing but, dear, try to understand everyone, it never means that you should write 2 square plus 2 square into this and so on. This is the just way to find out the error. So error is nothing but just take first error free value, that means true value of both. So here 2 square into 10. This is our power without error. This is our power without error. Now error in power is nothing but plus minus. How much error in current, dear friend? 2%, and power is also 2. So 2 into 2% plus. How much power here, dear friend? 1. So 1 into percentage is 1. So what will be the final answer? 2 square into 10. So 40 plus minus 2 and this 1. So I think 5. So this is our final answer of power. So in that type of things, we have to simply add all the error. Whatever power is given, then multiply power with the amount of relative error. Please mind it. Yeah, good evening, Narsimha. And 2 watt absolute error percentage. Okay, whatever. Yeah, it is clear to everyone. Now, I'm going to give you 2 examples for homework, and please try to understand or try to solve all these problems. Okay. So this is your first problem. Calculate the maximum percentage error in I. Okay. Please mind it. Calculate maximum percentage error of this I. Sorry. So this I. Here we have 3 current sources, and according to KCL, we know that the algebraically addition of currents at a particular node is always 0. By that thing, we can calculate all these things. Okay, so love you, dear. Now, but beta ji, please try to understand, you have to do hard work because we are very close, okay, about GATE 2020. So we don't have much time, okay. Very good evening, beta ji. So this is your homework example, and next example I am going to give you. Please mind it, this one, okay. So just take a screenshot and try to solve these problems so that you can improve your knowledge. Sir, we need to convert relative to absolute. Yeah, definitely, Preeti, but try to understand here. Again, I am going to say, I think you have still some doubt. Listen to me carefully. At the time of addition, subtraction, we have to take absolute values. And at the time of multiplication, division or power terms, we have to consider relative error. Okay. So please keep that sentence in your mind. So yeah, good evening everyone. So now this is beta for next example for you. And now this is the example. So read this example carefully and try to tell me what will be the answer. Yes, everyone, first read it. So okay, Venkatesh, sir, in the sum error our percentage need to convert into absolute? In the sum error, yeah, if we have some percentage error in the addition, then we have to convert into absolute, definitely Venkatesh. And one more thing, if we don't want to convert, then we can directly handle by another approach. Okay, another approach is nothing but whatever percentage error is given, consider that is relative error, nothing else, it is a relative error, and add all relative error directly. Okay, just wait a moment. So just read this problem carefully. I'm going to tell you one concept more. Suppose dear, in addition of two quantities, we have percentage error or relative error. So I'm going to write here, beta ji, suppose in A is nothing but del of A percentage plus B del of B percentage. Okay. So now we want to add both values. So here we can write some del A error divided by A is equal to del A by A plus del B by B. So here you can use relative error, and finally error we can calculate del A is equal to this overall terms whatever is coming into A will be our final answer. That is another approach. If you want, you can handle it or you can apply it. Okay. Now dear friend, I am going to read your problem. A voltage V1 is measured 100 times and its average and standard deviation are 100 volt and 1.5 respectively. Okay. Try to understand. Kind of we have taken 100 times voltmeter reading, okay, of any load, and standard deviation we have to use here, and you know very well average, mean, all terms. Okay, according to that person is saying we are receiving 100 volt with 1.5 standard deviation. Similarly, he is saying, or he or she, whatever, a second voltage V2 which is independent of V1 is measured 200 times. That means, dear friend, we have two different loads. Maybe one load is going to measure, or one load is going to provide 100 volt, second load is going to provide 200 volt with some different type of standard variation. And in the third line, he is saying what will be the standard deviation in V3 if V3 is nothing but V1 plus V2. V3 is nothing but V1 plus V2. Dear friend, all question whatever I provided to you are from GATE or like ES or IISc exam. I'm not even going to consider a low concept type problem. So try to handle all these problems with your like absolute honesty, so that we can discuss each and everything. Whatever you are facing doubt, please let me know at the same moment, and it is my promise, okay, we will handle or resolve all those things at the same moment. Okay, so now somebody is going to reply 2.5 volt is one answer. So night. Okay, so now see dear, everyone knows it, beta ji, what is standard deviation error kind of is nothing but, suppose I say some sigma V3 is under root of del V3 by V1. Wait a moment, here I wrote something wrong. So this is, yeah, del V1, del V3 by del V1 into summation or sigma of V1 square plus del V3 by del V2 square into summation of V2 square. This is the formula, and from where we can get that formula? It is very easy. Okay, Preeti, we will match beta. Now see, from where we can get that formula? Dear, that formula is very easy. We learn that type of concept in mathematics, in signal system, as well as in measurement also. Okay, sometimes in circuit theory also. So please try to understand, aware with the concept of standard deviation. So here, dear friend, I am going to write sigma or like error in, or standard deviation error in V3 is nothing but derivative of this one. So del V3 by del V1 differentiation partial is nothing but V1 is here, so 1. Similarly, del V3 by del V2 is also 1. So 1 square, 1 square. And what is the error in this? 1.5. Wait a minute. Okay. So this is the thing. Just wait a moment. Yeah. So here, this is the standard deviation in first case 1.5, and here the standard deviation in two case 2 volt. So we have two. Yeah, hi beta ji. Purushottam. So now here we have a standard deviation 1.5 and 2. Please mind it, everyone. A standard deviation, they will, in general, they will provide in absolute way. In general, they will not provide in relative. Keep all this bit things in your mind. Because, dear friend, a small error, or we can say a small error can give you, unfortunately, some negative mark. Okay? Try to understand basic things. Where we should use relative, where we should use absolute. So here, in general, they will provide absolute. If they are going to provide relative, then definitely we have to convert in absolute. So here, most important thing, whatever I wrote here, dear. So here, our sigma V3 is equal to under root of del V3 by del V1 square into sigma V1 square plus del Vy3 del V2 square into sigma V2 square. So these values are 1 and 1. Just put 1.5 here, 2 here, squaring and under root, and tell me final value sigma V3. Yes, anyone? So Knight replied me 2.5 volt, Preeti replied me 5 volt. So just see, it is better. So 1.5 square is 2 square, so 4. It is around like in greater than 3 and less than 4. So around this value, and 2 square is 4. So 4 and 3 point something. So 3 and 4 something. So we can say around, yeah, thank you Vishal, it is coming 2.5 volts. So our final answer is 2.5 volt. Please mind it, everyone. Our final answer is 2.5 volt. Okay. So here's some limitation of time. So my dear friend, I'm going to again provide you some problems for the homework. Just read all problem carefully. Okay. When you are free. So this is your next example related to error. This is your next example related to error. Please try to handle all those things. And this is very, very important example now I'm going to take. Try to understand that variety type. Okay. Because whatever I provided 4 examples for the homework, dear. These 4 examples I'm not going to say are very easy, but no doubt not complex. So try to solve it all examples. It's my request to everyone. If you have any doubt, please let discuss with me tomorrow class. Okay. And now think is most important, this question. So read this question carefully and tell me what will be the answer. So here our final value or formula T is given, and this tension is nothing but, dear friend, T is equal to RGH by 2 into something. Leave this thing, no issue. We want to calculate final error in the measurement. So what will be the percentage error in the tension or surface tension, whatever mentioned. Okay. Thank you everyone. Now listen to me carefully. Here the percentage error or relative error or absolute error, nothing is given in any value. See, given diameter of something without error, rise of water without error, simplifying something, gravitational constant is also without error, determine possible percentage error in the surface tension. Most important thing, when percentage error, relative error or absolute error is not provided, please mind it everyone, always consider significant figure. Okay, always consider significant figure, because that significant figures will provide us the amount of error. Please mind it, the amount of error. So what is the value here? It is something meter. So we can write D is equal to 1.25 into 10 to power minus 2 meter. So we can write, I think, 0.00125. Just see whether it is right or not. Okay, I'm just writing simply. And then it is, yeah, I think it is 0.010 only. Okay, so this value. And what about, dear, height? Height is nothing but h. We can write 0.045 something. So what will be the significant of h? So significant figure of h is nothing but 0.001. You have studies in 10th and 12th also. Significant figures are nothing but from mathematics only. and significant figure for D is nothing but 0.001. Okay, so these are the significant figures. Now see what formula we are going to use. T is equal to RGH by 2. So here error in the T, del T is nothing but, dear friend, G is constant, gravitational constant, and it is standard value. So nobody can introduce any error in general in the G value. So that error is 0. Now dear friend, it is very easy. We required only R and H and multiplication of R and H. And in multiplication, we can directly add relative error. So what is the significant error? Is nothing but in D, it is 0.00. Here we required R. So D by 2 and D by 2 we can say, and 2 cancel. So whatever value we will put, by both values, answer will be same. So here dear friend, 0.0001 divided by, we can write 1.25 into 10 to power minus 2 is first error. Okay, and divided by 2 also, so both will cancel. And plus another thing is 0.001, this height, divided by 0.0145. Please mind it, my dear friend. That formula or that example was very nice example. So keep that point in your mind also. Sometimes significant figures are mainly responsible to find out the error. So try to handle that type of problem also. Okay, you should, I think, according to me, you should attempt 2 to 3 or sometimes more problems, more problems related to significant figures also. Here I again explain, maybe you have some doubt also. So here dear, del or T is equal to RG as something, so G is a gravitational constant, and gravitational constant is universe wise standard value, so we are not supposed to like assume any error in the gravitational constant. What about R and H? R is nothing but radius. Dear friend, if we want to calculate radius with the help of diameter, so D by 2 and D by 2, so 2 and 2 cancel. So that value will give us some error. Similarly, what will be the error in H? Error in H is nothing but significant figures divided by the value of H will give us relative error. If we will add both, then we can have, or we may have, final error. And somebody reply me, it is 2.73 whatever. Please try to understand. Calculation part doesn't matter. Try to understand all the concepts. Okay, so thank you everyone, and we will meet tomorrow at 4:30. Okay, thank you. If you have any doubt, please let me know. Yes, anyone want to say something? Please, most welcome here.